Welcome to part 6 of the 2-player pinball machine build. In this episode, I very thoroughly show how I built the flippers. This is a key part of the build because it's the main interaction between player and machine. It has to be built right, and it has to be built well. If not, the entire machine will be flawed, so no pressure. In addition to showing you what worked, I'll also show what didn't work. So if you ever decide to build your own, you can learn from my mistakes. I already made the template for the flipper based on the limitations of the rubber band that goes around it. So I used that piece to make the 4 real flippers out of birch wood. Without the band, it measures 2 5/8 inches long and 1 inch wide at the fat end. With the band, it measures 2 7/8 inches long and 1 1/4 inches wide. I marked the circular center of the fat ends to begin drilling for the bolts. I started small and progressively worked my way up to the diameter of the bolt. I'm going to be using a carriage bolt for the flipper, because carriage bolts have a square bit at the end of the threading. When I chisel the space for the square, it'll cause the flipper to rotate with the bolt. I was using a new chisel, so I did a test with the excess birch. The bolt seemed quite secure. The square space only goes down as far as it needs to. I made a dumb mistake and hammered the wood into the bolt instead of the bolt into the wood. It caused a crack that ultimately ruined the flipper. So I made a new one. I swear, this wood is really durable, just not when you hammer it like I did. Next, I moved on to the board. I already marked the spots for the holes when sketching the layout, so I went ahead and drilled them. A washer sits between the flipper and the playing surface to prevent friction. I did a test and was relieved to see that it could push a pinball to the top of the ramp. It gives me hope that this crazy idea will work. Next, I placed the flippers in their resting place and taped them down. It was important that the positioning is accurate, or the next step will be a bit difficult. On the underside of the board, blocks will be connected to the bolts and forced to rotate by sliding blocks pushed by the players. That'll make more sense as I put it together. I marked and drilled holes in the blocks 3 inches from the end. Any more than that and they would knock against each other in the center, or cover that hole. I put a washer down before the block. Now I'm going to use epoxy for the first time. The goal here is to make a solid connection between the wood block and the bolt. An all-purpose epoxy is probably the best way to make that happen. The type I used is a quick set, so once it's mixed, I only have a few minutes to use it until I have to make a new batch. I first connected the washer to the block. Unlike the other washers used, this one won't be eliminating friction. The next part of this is to add a nut. I applied epoxy so there would be some on the inner threading. Then I glopped some on the outside. The nut had to be tightened down just enough so that it would eliminate the wobble, but not so tight because the flipper needed to move freely. Following the regular nut is a nylon locking nut. In addition to the epoxy, this will help keep everything in place. The combination of epoxy and force from the nuts will keep the structure nice and solid and working properly. Next, I open the package of kydex plastic. There's going to be quite a bit of wear and tear from this machine, and the idea is that if I use this plastic to take the impacts, it'll prolong the life of the wood. Therefore, on any surface that'll see quite a bit of friction or repetitive impacts, I'll put a layer of kydex. I'm going to speed through this next section because in the end it won't matter. I added a stopper block that would limit how far the flippers could rotate, although I ended up taking this piece out for reasons that I'll explain in a minute. I'm glad I took it out because the noise is way too loud. That's not the real reason for getting rid of it, but it's a bonus. Next, I cut out the actuators and guides. Again, birchwood. The curved ends will be the part that push against the flipper block. When glued down, those two side blocks will keep the sliding piece in the right spot as it activates the flipper. To make sure the slider won't get stuck, I used a few pieces of paper as spacers. Since I don't have a planer, I had to spend some time sanding down the sliding block to eliminate the friction fit on the top and bottom. Next, I moved on to adding some kydex plastic to the ends of the sliding blocks. The ends are curved, so I had to mold the plastic to match the curves. Part of the reason I got this plastic was because it can be manipulated when heated. The first go at it was a fail. I basically stuck the marshmallow right into the flame and burned it. When the surface is bubbled and cracked, it kinda defeats the purpose of eliminating friction. Round 2 went much better. I exercised patience and let the plastic gradually heat up. I held the piece on the curve, so while it cools down, it hardened in the correct shape. The plastic on the sliding block seemed to work well, so next I added the rubber bands to automatically reset the flippers. It was a big relief to see that the flippers have the capability to send pinballs over the hill. You'll start to see the major issue with the stopper block. With the full action of the sliding block, the flipper jams. Here, you can see that due to a combination of the guides, flipper block, and stopping block, the sliding block gets pinched. The rubber bands aren't strong enough to overcome the pinching force, so it just stays there. You'll see a few attempts to troubleshoot the issue. The first attempt at a fix was to add a small plastic surface to eliminate that top arrow friction. I let that dry for a bit before seeing if it solved the problem. In the meantime, I worked on adding the pieces for the neighboring side. The main difference between the first one and this one is that there's a layer of kydex plastic on the inside walls of the guides. Just the sides, not the top or bottom. This side was kind of getting jammed, but not as bad as the other side, which is still jammed, so I added another guide with a plastic layer. It seemed to improve the situation, but the problem was not completely gone. I tried a million different combinations of rubber bands to see if that made a difference. The different colors were all different thicknesses, and thus different strengths. None of that seemed to completely solve the issue, so my final solution was just get rid of the stopping block. But before doing that, I just needed to trim down the actuators. They needed to be flush with the side when fully pushed in. Alright, clearly it was time to get rid of the stopping block, so let's get that out of here. It's not the prettiest sight to see, but it's on the underside, so it's all good. I sanded down the edges so no extra fragments could wedge underneath the flipper blocks. The last pieces to build for this section are the ends of the sliding blocks. The two pieces here will be what the player pushes against to move the flippers. Since these circles are bigger than the square hole, they'll simply act as the stopping block, but from the outside. And from there it was pretty simple. I just found the center of the knobs and screwed them into the center of the blocks. I used a countersink to bury the screw head so it could eventually be covered up. I had to do one last thing, and that was to put something in place to stop the flippers from retreating too much. So I took off the rubber bands and taped the flippers down in the depressed position. Then I hammered in a few nails. I'll most likely change this into something a bit more robust, but this will work for now. And that'll be it for this video. I know this was a long one, but making the flippers is a complicated process that requires a detailed explanation. And again, if these don't work right, then the rest of the build is kind of pointless. I'm already planning on reworking the rubber band situation to guarantee no jams from the sliding block. That'll be addressed in a later video. That's it for now. See ya!